Okay, perfect. So, hi everyone, I'm Martinez. I'm the president of the CLI Society, and first of all, welcome everyone to the launch of ClimateHack.AI 2023. Of course, hi everyone, I'm Martinez. I'm the all good?
We're all good.
Okay, anyways, coming back to the topic, of course, we'll go through all the technicalities and how competition is going to happen just in a minute. But first, let's take a step back, just understand how it all started. So, as any AI society, of course, we're focused on gathering this large community of the AI enthusiasts through various events, incubators, and competitions. However, at some point, we started to ask ourselves, what's the true meaning of this knowledge exchange? I mean, after all, we managed to gather this community full of individual and talented individuals. However, can we make something impactful out of all this? And of course, I mean, as individual societies, we may not have enough resources to tackle and cope with these larger challenges. However, if we gather together, we may as well have a shot at it. And this is where the idea of ClimateHack.AI was born. So as a student-led initiative, we now have over 25 universities from UK, US, and Canada with an idea to tackle climate change. 2 years back, we were fortunate enough to organize the first iteration of the competition, and I was fortunate enough to be one of the finalists there as well. And believe me, it was truly an amazing experience. Of course, as a finalist, I had a chance to meet many talented individuals, improve my technical skills as well. But most importantly, I had opportunity to actually work with real world problems and create a real tangible impact, which is uncomparable any kind of student-led hackathon standards. Considering the success of the last competition, we're launching the second iteration of the competition with all the partner universities and our core organizer, Doxa.ai. So without any further ado, let me introduce you to Jeremy, the CEO of Doxa.ai, who will explain the technicalities of the competition. So, Jeremy.
Well, thank you very much. Thank you very much. Thank you for that warm welcome. And, welcome back to everyone here, not just in person here at UCL, at University College London, in the glorious Roberts building, but everyone around the world joining in from the stream, which is why I have to stand in this awkward position. So yes, welcome to the launch of ClimateHack.AI 2023. This competition has been a long time coming. We've been working on it for quite a while sometime, but we're super excited to see we're back with a more ambitious challenge than ever. And this is honestly one of the largest opportunities that you have as a student to help directly contribute to cutting carbon emissions. So this was the slide actually I was meant to speak over, but welcome from all of us here at the UCL AI Society in London. ClimateHack.AI is an international initiative. We're bringing together this year 20 AI, data science, and machine learning clubs from about 18 universities in the UK, but also the US and Canada. So hello, everyone over there. And this year, the competition is graciously supported by 5 sponsors. New Cross Healthcare, who supported us last year for the previous competition, but also UCL, PGIM, Open Climate Fix, who are also our challenge provider, and ClimateX. So thank you very much to all of our sponsors. We wouldn't be able to do this without you. So, as Martinez mentioned, ClimateHack.AI, this is a fantastic opportunity to help tackle climate change with machine learning. And I thought it'd be fun for us just to take a moment to talk about the background to our challenge. So, grid operators around the world of electricity systems, they schedule natural gas turbines on standby, well, not on standby, but ramps down below their full capacity, because solar power is variable, especially in countries like the UK, where this challenge is really focused on clouds come and go, weather happens, and unfortunately it means solar power is incredibly hard to predict. It's actually one of the largest sources of uncertainty in our power system, and unfortunately that leads to quite large problems, because it means that grid operators need essentially additional capacity based on fossil fuels in order to make up for any shortfalls in supply and demand. So they have to be matched pretty much instantly, otherwise we end up with blackouts and all sorts of terrible things. So what that means really is if we could predict solar power generation a lot more accurately. We'd be able to cut this spinning reserve, as they call it, of natural gas turbines that we have, and also cut costs. So last year, here's a photo from the finals. It's absolutely fantastic. It was a really great event. We had a challenge all centered around predicting future satellite imagery. And that's really useful because it allows us to predict the movements of clouds. Of course, if a giant cloud comes over and covers all of your solar panels, you're not going to have a great day. So what does that mean? Well, we had some excellent finalists last year. The University of Illinois and Urbana-Champaign won, and then there was also Toronto and CMU. And those contributions from that challenge have helped Open Climate Fix directly make a model that was the best that they'd seen so far for predicting cloud movements. But we want to go further. So we are back with a more ambitious challenge. This year, we are challenging you as participants to help build a site-level solar power forecasting model based on satellite imagery, on weather data, on air quality data, based on particulates. That really pushes the state of the art forward. And this is how we're hopefully going to get to that 100 kiloton per year impact in carbon emission reductions. So what data have we got? We've got a lot of it, more than we need, really, realistically. Of course, there's historical solar power generation figures for Great Britain. And actually, for this challenge, we'll be giving you an hour of solar power generation history in. And then your task will be, along with this historical data, to predict the next 4 hours of solar power generation. And that's going to be as a proportion of total installed capacity. So it's a number between 0 and 1. But you also have high resolution visible and also non-high resolution visible satellite imagery. So these are channels like infrared and a load of other things that these big these big satellites pick up. Eduardo, could you play the video? So you might be wondering, why do we care about satellite imagery? After all, we're predicting solar power. Wouldn't this be related to the weather? But actually, oh, I see the video is on the stream. Imagine the video. That's probably going to be how we do. These are art scenes for everyone who's watching it online. But essentially, when you have clouds that come over the UK, even if they're fairly patchy and fine-grained, it can still have a huge impact on solar PV yields. Of course, when it's nighttime, solar power yields drop, but also just when you have fine mists and things that might show up on satellite imagery, that can have a huge impact. For everyone here in person, if you look up the Doxa competition page, you will see the video that's meant to be playing here. Of course, we also have weather forecasts because the satellite imagery is fantastic, but it's even better in combination with traditional weather forecasts. And actually, we're giving you a lot of weather data, 38 data variables in fact. And here some of it is. You have things like ground temperatures, things related to snow, wind speeds, and all sorts of other things. And it actually looks quite nice. It's great. Precipitation and so on, and also things at different altitudes. There's a lot of data here, more than you could even possibly need. And that's actually part of the challenge here. We really want you to be creative and try and figure out what data is actually helpful for this problem and what data can get by without using. Because ultimately, if models are smaller and more lightweight, they're going to be easier to put into production. And if we need to collect less data in order to produce more accurate solar power forecasts, then that also increases the extent to which we can actually deploy these models, which is really exciting. We also have air quality forecasts. Here it is. It's a particular favorite on my team, dust. And you can see all of these huge dust clouds over the UK at, I believe, various altitudes in this case, although actually at various time steps. Dust can actually have a huge impact. And actually, other gases and other air particulates can have a huge impact on solar power yields. Things like not only dust, but also NOx's, other gases can affect the path of sunlight through the atmosphere. So another part of your task as part of this challenge is to figure out, using all of the test data that we have from physicochemical tests that get run which of these variables can actually be useful. You have, I believe, 12 or 13 of them, and you have them at 8 different altitudes throughout the atmosphere. Because it may be that, ground level dust, for example, matters more than dust at 50 meters or 1,000 meters. But that's something for you to find out, experiment with, and integrate into your model, hopefully. So yes, as I was saying, please be creative. The main task here for this challenge is to build a really cutting-edge model, if you can, that is both accurate by minimizing the mean absolute error, and as you're going to be ranked on the leaderboard, but also that's performant. We want models that are relatively fast, and this is actually something that becomes a more important criteria in the finals, which we'll talk about in a bit. Why is it important to have a performant model? It's just so we can deploy it as widely as possible, so we can really have the largest impact. And as I said earlier, there's a lot of data, gigabytes of satellite imagery, of weather data, of aerosol data, of historical PV data. You probably don't need to use all of it. So have a go, take a look through, see what you might want to use, come up with an interesting strategy, and we'll go from there. So the timeline then. Today, of course, it's the launch. You can enroll from today. We're releasing more tutorial resources from tomorrow, which will allow you to actually step in and get started. You've got just under 10 weeks to work on this challenge, taking us to the start of February, and then we'll have finals a month later. The finals this year will be for UK-based participants here at UCL, where we're doing our launch, and also for the North American participants at Harvard University, courtesy of our great friends at HUMIC, Harvard's machine intelligence community on their end. I should also mention that for finalists, we'll do our best to support you and subsidize your travel and accommodation expenses where we can, and there'll be further details on that posted on the website. Finally, in this section, we have our prizes. There's a £20,000 prize pool for our winners, and in first place, if you place first at our finals, according to our judging panel, of course, who will look at all the presentations and look at your work over the past couple of months, at that point, you'll win £10,000. That translates into roughly $12.6 thousand. In second place, you'll get £6,000, which translates into about $7.6 thousand, and then in third place, you'll win £4,000, or about $5,000 US. So to get started then, go to the ClimateHack.AI website. There'll be a load of information on there, and actually from tomorrow after this launch, there'll be a lot more information on all of the other details of the competition. Take a look through, and then when you're ready to take part, just click participate. That will take you to the competition page. On that page, you have all of the technical information about the challenge, things on what all the weather variables are, what the actual machine learning task is in detail, and a load of other useful information, some graphics and so on to help you get started. And this is where we'll be posting tutorial resources from tomorrow to allow you to submit. On that note, please also make sure you join the ClimateHack.AI Discord server. The Discord server is really where we're going to be posting announcements throughout the course of the competition. So if you want to know what's going on, the Discord server is the best place to go for it. Also, it's where you can ask questions in the forum channels, whether it's related to the competition more generally, or if it's a technical support question that we could probably help with, either to do with the platform or your submission in another way. I should also probably mention, we need to be able to verify your eligibility. You need to be a student enrolled at one of the 18 universities where we have an AI or data science society participating. So please make sure if you do sign up to use your university email so we can verify that. So that's it from me. All of the other technical information will be on the challenge page, so I won't bore you by reading all that out now, but I just want to say good luck. And once again, this is one of the most impactful challenges you could work on during your time as a student, and I really look forward to seeing what you all build. Thank you very much, everyone. And bye to everyone on the stream. Everyone at UCL will be heading to the IOE bar after this. Thank you very much.